Hi, I'm Jim Lake. My friend Paul and I have taken on a new project. We want to build the Douglas XTB2 Sky Pirate, a late World War II torpedo bomber. It was built for the Navy by the Douglas Corporation, and only a couple of them were ever built. It wasn't a particularly successful airplane. It was very large, and it was slow, and it was heavy. It was designed to carry as many as 4 torpedoes that weigh approximately 2,000 pounds apiece. It required a lot of horsepower in order to be able to get that airplane off an aircraft carrier. And the only engine that the military had available at the time that was able to do it was the R-4360. It's a large 27-cylinder, 3,000 horsepower radial engine that represents really the peak of radial engine technology. It's the same engine that's used in the B-29. The problem for the Sky Pirate was that in order to be able to use all that horsepower in a single engine airplane, it needed 2 propellers, and the only practical way to design it with 2 propellers was to make them contra-rotating. Now, contra-rotating means that the 2 propellers were on separate propeller drive shafts that were coaxial. So they both spun around the same axis. In order to produce that motion, the Sky Pirate had a contra-rotating gearbox on the front of it that was driven by that big 4360. Now the Sky Pirate had 2 14-foot propellers, and those propellers are big enough so that the 2 of them operating in opposite directions were sufficient to get the aircraft off the aircraft carrier, but they were also heavy and difficult to deal with and difficult to maintain, and they were also notoriously loud. The model we're going to build is going to be approximately 1/8 scale. It will have a 96-inch wingspan, and it will have a nose diameter of just a little over 6 inches, which provides the maximum dimension of the gearbox that we're going to build. Now, my part of the project will be the design and the construction of the gearbox. And a gearbox like this for RC airplanes they're really not available. And in order to make this airplane as authentic as possible, we wanted to do it with a gearbox rather than doing it with some other technique that you can use to produce contra-rotating propellers. I'd like to actually design and build a gearbox that works just the way the gearbox was designed to work on the Sky Pirate. The model is going to be powered by a 3700 watt, which is approximately 5 horsepower electric motor, and it will drive 2 20-inch contra-rotating propellers. As I said, the gearbox is going to have to fit within the 6-inch diameter of the nose with some clearance and be able to mount to the firewall. So I'd like to design the gearbox with a maximum exterior dimension of no more than 4 inches. We'll see how that works out. Now, I've never designed and built a gearbox like this before. In fact, I've never designed and built any gearbox, and so it should be an interesting adventure. I have seen lots of videos that cover the making of particular kinds of machinery, but I rarely see anything that goes in detail into the design process, and that's what I'd like to capture in a series of these videos, this being the first one. I hope that you'll enjoy it, and I'd like to have you come along for the ride. Thanks. We'll talk about the design next. All right, before we get carried away on the gear design, I need to cover a few of the essential terms that describe the design of gears. the gears that I have on my little sample in front of you are spur gears, and spur gears have straight teeth which are cut parallel to the axis. The teeth of the gear are cut along a curve. This line right here is a curve called an involute, and the reason that an involute is used is when gears of similar involute curves mesh, they mesh along a straight line. That allows the gears to mesh by rolling against each other without sliding, or with at least minimizing sliding. The angle that that line of action produces with respect to the center line between the two gears is called the pressure angle, and those are standardized for gears which have been produced for the last, well, at least 100 years this way. The standard pressure angles that we'll find in commercial gears are 14.5 degrees, 20 degrees, and some of them at 25 degrees. Because they're common and easily found, I'm going to use 20-degree spur gears for this design. The next term that you'll find commonly relating to spur gears is the diametral pitch. The diametral pitch is the ratio of the number of teeth to the pitch diameter. Each gear, as you see here, has a circle around it. Where those two circles come in contact is the contact point between the two gears. Those circles are called the pitch circles, and the diameter of the pitch circle is called the pitch diameter. Spur gears are designed to come in contact with each other where their pitch circles are tangent to one another, as is shown in this drawing. Another term that's commonly used with gears, especially metric gears, now is the module. The module is the ratio of the pitch diameter to the number of teeth, and it's simply a different way of expressing the relative size of the tooth with respect to the size of the rest of the gear. You can calculate the module by dividing 25.4, the number of millimeters in an inch, by the diametral pitch. A few more terms. The distance between the pitch circle, which is the circle around the center of the gear where the teeth come in contact, and the tip of the gear tooth is called the addendum. And likewise, the distance between the pitch circle and the root of the gear is called the dedundum. The difference between the two is called the clearance, and the difference along the line of contact between the two teeth that are not in contact is called the backlash. Finally, we have got the contact ratio, which is an expression for the number of teeth that are in contact as the gears are in mesh. The larger the teeth of the gears, then the lower the contact ratio. The definitions that I've been using here come from Machinery's Handbook, and I recommend this book for anybody that's interested in machinery. If you haven't have a chance to get a hold of a copy of one, it's well worth the investment.